see how we are going to be applying them. Again, when you look at this side of laws of indices, as you can see, so I have some laws of indices. That's why I'm saying you can just pause the video, look for the notes on laws of indices, and then see how we'll be applying them, unless you are able to see this one. Like we can see the first one there, we have a to the power m times a to the power n. So we are multiplying two numbers written in index form while their bases are equal. If that happens, we add the powers. For example, if we have 3 times 3 to the power 2 times 3 to the power 3, in this case, we see that the bases are equal. And under multiplication, we take one base and add the powers. So we have 3 to the power 2 plus 3. Now 2 plus 3, these are the two powers from the numbers that have equal bases. Or let me say, these are powers of base 3. Now, this means 3 to the power 2 plus 3 can be written simply as 3 to the power 5. Now, law number 2, we look at division. When we divide two numbers written in index form, we subtract the powers. If we have a to the power m divided by n divided by a to the power n, this is equal to getting one base a, then you subtract the powers, that is m minus n. Then we have a to the power m. If a number is raised to the power, it means it has to be multiplied as many times as that power. Then if we have a number which is a base raised to the power, a fraction, and that fraction is a negative, this can be written as 1 over that base to the power n over m, which is the power. Now if a number which is a base is raised to the power negative, or to a negative power, suppose we have what we have here, let me just write it here so that you can see. We have a to the power negative m, right? This can be written as 1, right, over a to the power m, right? So we'll be applying this. You see, we've talked about this one, and then here you also see we're going to apply this one and that one and this one as well, right? So you can pause, write these some of these laws down, and then we are going to see how to apply each one of these in the questions that we have. Okay, so you can write them down, then as we solve, see how each law is being applied, right? Right, let's get started. The first question we have is evaluate the following. So remember, we are evaluating, but then some we are simplifying. Okay, I'll be telling you that this one we are simplifying, this one we are evaluating. Like this one will just be simplifying. Now the first one here, we know that any number to the power 0 is simply 1, right? Good. Now 2 to the power 6, what are we getting? If we have 2 to the power 6, now we look at 2 to the power 6, right? This part and this part, we see that they have equal bases, right? The bases are equal. Now look, what do we do in division? So if bases are equal and we are dividing two numbers written in index form where the bases are equal, you subtract the powers, right? So we are going to do that. So we're going to take to get one base, right? And then we are going to subtract the powers. Now this will give us 1 plus 2, that's 6 minus 6 minus 3 will give us 3 there. Now this will give us 1 plus 9, right? Good. Sorry, not 9, but this will give us 8. If we add, that's when we are going to get 9 there, right? Okay, good. Now we can proceed. Good. So here we have 25 to the power 3 over 2 plus 144 to the power 1 over 2 times 4 to the power 1 over 2. So what we can do there is to rewrite this. Now we know that this means we need the square root of 25, right? So we need to find the square root of 25. So there is where we put that 2. Now that 3 on top, it means it will be the power of what you are going to get, right? Same applies to this one. This means we need to find the square root of 144, right? So there, I'm not supposed to show these 2 here because we know that the square root, we want that. Now here we have times 4 to the power half. This means we need the square root of 4. So there we have 2. Now this is raised to the power 1, right? Sorry, that's to the power 1. Okay, so that's in bracket. Now if we do that, we see that we are going to have 5 to the power 3 plus the square root of 144, that's 12, right, to the power 1. Now this multiplied by 2 to the power 1. Now this will give us 125, right, plus this will give us 24. Now if we add this up, we are going to get 149. So we have evaluated this one, right? So we can solve this one as well, right here, before we go to that one. So here what we have is 4 to the power 4 divided by 4 to the power 2k divided by 16 to the power 3k. So according to laws of indices, we can balance the bases. We first deal with the first 2 things. We see that they have equal bases, or if you don't want that, you can just reduce everything to 2, right, so that you have that. So 4, the first 4 can be written as 2 to the power 2 and then raised to that power 4. And the second one can be written as 2 to the power 2, right, now raised to that power 2k, which we have to multiply, right? Then we are going to have again divide by 16 can be written as 2 to the power 4, right? Now this will be multiplied by and that 3k we have. Alright, good. So we are going to get just one base since all the bases are equal. Now 2 times 4, that will be 8, right? Minus 2 times 2k, that will be 4k, right? Minus 2 to the power, okay, that's 4 times 3k, that will give us 12k, right? Now simplifying this further, we are going to have 8, that's 8. Now negative 4k minus 12k, that will give us 16k. So minus 16k, right? We can't go any further than this, so it ends there. Good. We okay, let's now answer this one, right? So we have 2 to the power n minus 4 times 16 to the power 1 plus n. That is our numerator. The denominator is 8 raised to the power negative n times 4 raised to the power negative 4 plus 1. So we are applying again laws of indices. Remember, multiplication, we need to make bases equal, and one way we can do that is to write 2 to the power n minus 4. Now we have multiplication there. 16 can be written as 2 to the power 4, right? Now that power 1 plus n can be multiplied like that, right? Okay, cool. Now we can see that we have equal bases on top. Okay, let's leave that and do the same to the bottom. So here we can have 2 to the power remember that's 8, so to the power 3, right? To the power that's to the power 3, then multiply by, that's negative n. Good. Now times this one, we have, it's 2 to the power 2, right? Because that's 4. Now multiply by negative 4n, right? Negative 4n plus 1. Now look at on top, the bases are equal. At the bottom, we have also made the bases to be equal. So that means we can add the powers while we take just one base. So this is the power for the first base. So we have to add the powers of another base, which is 2. So we have 4 times 1, that's 4 plus 4 times n, that will give us 4n. Good. Divide this by, we have 2. Now 3 times negative n, that will give us negative 3n, right? Plus, we are adding the powers, remember. Okay, so that one, we know that what we are going to get here, we need to add powers, but we have, so plus 2 times negative 4n, that will give us negative 4n. Again, 2 times 1, this will give us plus 2, right? So on top there, we see that if we do that and that, okay, right? Now 4n plus n there, we are going to have 2 to the power 5n, right? Now over at the bottom, we have 2 to the power negative 3 minus 4n plus 2. This will give us this will give us 2, right, to the power, that's negative 3n minus 4n, that will give us negative 7n, right, that will give us negative 7n. Okay, it's negative 7n plus 2, right? Now look at what we have here. It is the same as we are dividing, right? What we have here is same as having 2 to the power 5n, right? Dividing this by 2 to the power negative 7n plus 2. Now this will mean we are subtracting the powers under division, right, according to the laws of indices. So that means we are going to have 5n minus 7n. So this is 5, this is 5n minus 7n. Remember, this side we are multiplying a negative with that's negative 7n, right? That's negative 7n, which will be positive, right? Because we are subtracting the powers of this base here, right? So we have, it will be positive 7n minus 2, which will finally give us 2 to the power now 7 plus 5, 7n plus 5, that will give you that's 12n, right? That's 12n minus 2. Okay, good. So that's good. Again, you can simplify that and get 2 to the power 2, right? If you simplify that, you're going to have 6n minus 1, right? Which again can just give you 4 raised to the power, that's 6n minus 1. Good. So there we are done. We have simplified this one, up to this far. Okay, now is there any one remaining here? I don't think so, so we can move on and solve these other ones here. Okay, we have some more. We have these two, right? So let's start with this one here, right here. We have 100 over 4 raised to the power negative 3 over 2. So which law are we going to apply here? So you look at this one right here. We have a over b raised to the power negative, look at this, negative n over m. So it is raised to a negative fraction power. So if we have this, the power can be split to the numerator and to the denominator, and then after that we can divide that expression. So we are going to do the same to solve our question here, right? So we are going to do the same, and we are going to apply that law. So if we do that, we can split the powers, and that means we are going to have 100 raised to the power negative 3 over 2, right? Again, at the bottom, we are going to have 144, right? 144. This will be raised to the power negative 3 over 2, right? Now, what does this mean? Well, this means that we can write this as a division, which means because of the power on top, we are going to have 1, right? Raised 1 over 100, right? That's 100. I don't want to do everything at one time. So that's 3 to the power. That's 100. Let me just write this properly. That's 100 raised to the power 3 over 2, right? Divide by, right? We are dividing this by, that's 144. That's 144. Now 144, which is because of the negative to the power, we have 1 over 144 raised to the power 3 over 2. Laws of indices, right? Now from here, this can mean that we have 1 over square root of 100, right? Because the power there, it means there we have 2. Inside there, we have 100, right? Now, this denominator we have is raised to the power 3, right? Now, this is being divided by 1 over the square root again of 144, right? The square root of 144. Now this is raised again to the power 3. Good. Hope you are following, right? Now from here we can simplify this. So this means we have the square root of 100, that's 10. So this is raised to the power 3. Divide this now by 1 over, that's 12, right? Square root of 144, that's 12. Now this is raised to the power 3. Now this can mean we have 1 over 10, right? 10 raised to the power 3. Multiply this by 12, right? Divide this by 1, which can just give us, remember 12 is raised to the power 3, which will just give us 12 to the power 3, remember, over 10 raised to the power, not 100, that's 10 raised to the power 3, right? Good. So you can use your calculator and find your values. If this comes in paper 1, you can just leave it right here, okay? Or you can multiply and find the exact values. Good, we can proceed and apply the same laws of indices to this question right here. Now this question we have 3 raised to the power a times 9 raised to the power a plus 1. So this is a plus 1, that's the power. Then we have 27 raised to the power a, right, to the power a plus 2, okay? This is what we have. Now if we do that, we can write what we have in index form so that we make equal bases. 9 can be written as 3, right, to the power 2n, remember. Okay, let me just write this step by step. I wanted to multiply directly, but I'm not going to do that. Then 27 can be written as 3 to the power 3, then a plus 2, right? Hope you are following even here. And now we have this square root. Now remember, since the bases are equal, there we can have a, we add the powers, plus 2a when we multiply 2 times a, then plus 2 times 1, that's 2, right, over. Now here we're going to have 3 to the power 3a, right, to the power 3a plus 6, right? Good. So this is what we got. Okay, let's do it now from the top here. I'm just going to do that, so to see that we are doing it from here. So again, this is what we have. Now remember, we have a plus 2a, that will give us, so we are dividing, so we have 3 to the power, this will give us 3a, right, plus 2 plus 2. Now we are dividing this, right, by 3 raised to the power 3a, right, plus 6. So we have this square root up to there. Again, this simply means we can subtract the powers under division, right? So if we subtract the powers, we see that we are going to have 3a, right, minus 3a, right, minus 6 plus 2. Let's have you are not confused here. Okay, now we see that this will give us a 0. Now negative 6 plus 2 there, this will give us right, this will give us negative 4, right? That's 3 to raised to the power negative 4, sorry. This is this will be 3 raised to the power negative 4. Good. Now what does this mean? This can be written as 3, right? This can be written as 3 let's do this. This can be written as 3 raised to the power negative 2, right? This can be written as 3 raised to the power negative 2, again 2, right? Now if we write this, we see that 2 there will cancel with the square root, and then we are going to remain with just 3 to the power negative 2, right, which will give us 1 over that's 1 over 3 raised to the power 2, right? Hope you're able to see how that is coming up. And finally, this will give us 1 over 9. Good. So this is how we simplify, how we evaluate this question. Okay, thank you so much. Now we come to equations involving indices. So we start with h. We have 3 raised to the power 2x is equal to 1 over 81. So our main goal whenever we're dealing with equations involving indices, your main goal should be to have same bases on both sides of your equation. Now you look at what you have here, right? 1 over 81, 81 can be written in index form as 3 to the power 4, right? Good. Now, what does that mean? That means you can have 3 to the power 2x is equal to 3 raised to the power negative 4. Now we see that the bases here are equal. So we are just going to remain with 2x is equal to negative 4. Now if you divide through by 2 and there by 2, what you are going to get is that x is equal to negative 2, right? So this is going to be your value of x, right? Right. That's cool. And if you want to prove, you can substitute x by negative 2 and you are going to find the same answer. So we do the same on f. We have 2 raised to the power 2x plus 16, 6, right? Not 16. God. Okay, no, that's good. Now 16 can be raised to 2 to the power 4, right? Now that power x will be multiplied with the power we have after, sorry, not 3 but x, that's negative x. After writing 16 in index form, which is 2 to the power 4. Now see that the bases again are equal, so we can equate the powers. That's 2 plus 6 is equal to negative 4x, right? Now if we put like terms on the same sides of the equation, okay, this mathematical sentence, we are going to have negative 6, right? Now this will give us 6x is equal to negative 6, right? So you divide through by 6. Okay, you divide there, you get x. You divide there, you get negative 1, right? Good. Okay, let's finish up here. We're just remaining with this one. We have 2x. Again, the square root of x is equal to 16. So we are saying we have 2x. Now this one multiplied by x raised to the power, this can be written as to the power half, right, is equal to 16 can be written as 2. Okay, before that, let us just write 16 like that. So we can divide both sides by 2 so that we can have we can remain with x multiplied by, right? This is what we are going to remain with. This side we are going to have x multiplied by x to the power half. Now remember, this x you have here is raised to the power 1, right? So we use the laws of multiplication where the bases are equal. In this case, our bases is x raised 1 raised to the power 1, the other one raised to the power half. Now 16 divided by 2, we are going to get 8. So this, if you add the powers, laws of indices under multiplication will give us x raised to the power 3 over 2, right? Now this will be equated to 8. So the base is unknown, and if the base is unknown, we multiply the power, or let me say we multiply both sides of the equation or we raise both sides of the equation with the power, the reciprocal of the power. So we have 3 over 2, right? Now the reciprocal of 3 over 2, that's 2 over 3, right? Is equal to 8. So 8 will be raised to the power, the reciprocal of what we had, that's 2 over 3. Okay, now here if you divide 2 into 2, 1, 3 into 3, 1, we're just going to remain with x, right, is equal to, now what do you have here? Here you're just going to have, this is 8, right? So you're going to have 8 here. Now in this case, you are looking for the cube root of 8, right, raised to the power 2, which will simply give you the cube root of 8, that's 2 to the power 2, right, which will just give you 4. So x is equal to 4. Thank you so much. Now let's do with this, the last one. So this one, we are going to start by dividing throughout by 2. Now if we do that, we're going to have x raised to the power negative of negative 2 over 3. We have here, we're just going to let it be 36 over 2. I mean, we can divide again. 36 divided by 2, this will give us, that's 18, right? That's 18. So this is what we have. Now we have base is unknown, it's x, which means we are going to work with the reciprocal of negative 2 over 3. So x raised to the power negative 2 over 3. Now its reciprocal will be negative 3 over 2, right? Now that will 18 on the other side of the equation is going to be raised to that power over 2, right? Now here, if you divide 2 into 2, 3 into 3, negative times negative, that will give you positive, so you're going to remain with x is equal to, now what this means is that you have 18, so you want the square root of 18, right? You want the square root of 18, okay, right? Now this is raised to the power negative 3. Now what does this mean? This means this can be written as that, right? You have 18 there. Now does 18 have a perfect square root? No. So you can just leave your answer in this form, or if you have a calculator, you can find the exact answer. So thank you so much for watching this video. Make sure you subscribe to my YouTube channel for more videos like this one. Remember to share with your friends, your classmates, and also like my videos so that you can get an update anytime I post my new videos.